Hi everyone, welcome to my class. In this class I'm going to discuss about the number system. Here we're going to learn about the different numbers and the different terms which you come across in maths, okay, at least till class 10 level. We will start right from the beginning. In the beginning, when we join school, we are taught these numbers. Let me write it down. The first number which you come across is 1, 2, 3, 4, 5, 6. In this way it will go on, and the last number we don't have any, actually we could denote it by infinity. It will never end because 5, 6, after 1000, 1 lakh, it will go on. These numbers starting from 1, they are called the natural numbers. They are called the natural numbers, and it will be denoted by the letter N. And these numbers are also used for counting. When we count anything, supposing we want to count how many fingers are here, we use 1, 2, 3, 4. So we always use these numbers for counting. So they can be called the counting numbers. So the natural numbers are the counting numbers. So we can say the natural numbers are the counting numbers. Okay. Now when we include 0, when we don't have anything, 0 means nothing actually. So it's a number again. Supposing you have to represent something when we don't have anything. Say, how many fingers are here? You'll say 1, 2, 3. If you don't have anything, so you have to represent it with something. So we have nothing. 0 is also a number. So when you include 0 along with the natural numbers, so when you 0, 1, 2, 3, 4, then the numbers are called whole numbers. So that means whole numbers includes 0 and the natural numbers. And whole numbers, remember, it's denoted by the letter W. So when we write later, when we will write N will stand for the natural numbers or the counting numbers. Natural numbers, the counting numbers are called natural numbers. W will be for whole numbers. Now, slowly we come across the negative numbers. So we have -1, -2, -3, -4, and so on. It will go on. The number will keep on decreasing. And the last number, supposing if you go on, it will be minus infinity. We don't know what will be the last number, so we just write minus infinity. So this negative numbers and the natural and positive, all this will be under one group. They are called integers, and integers are denoted by the letter Z. Then slowly we learn about the fractional numbers, fractions, like for example half, 3 by 5, and so on. Or the decimals, we have decimals. Decimals also, there are 3 forms. Like this is one form which terminates. Then we can have a decimal which does not terminate. Then we can have a decimal which never ends. Say for example, different numbers, non-terminating, not repeating. We will be learning more in detail. And we also have the root numbers or the radicals, maybe a square root, cube root. These are the different types of numbers which will come across in maths. And all these numbers, everything, whatever numbers so far we come across in class 10 level, we will put them under one group. And that group we will call them real numbers. Okay. All the numbers so far we have discussed, they fall under the group real numbers. Now before discussing real numbers, let me just tell you which are the numbers which will be non-real. At least till class 10 level. So non-real numbers. So non-real numbers. In maths, if you come across any number which is negative and if it is inside any kind of root, suppose it's maybe a square root or a cube root, you will directly say not real. This is not real number. Not real number. For example, root over -5 will be not real number. Root over -2, if it is minus, not real. But if it is root 5, it will be under real numbers. Okay, and root over -4, this also is not real. You cannot write this is not equals to -2. This will be wrong. You will just say not real. Because in higher classes, in 11, 12, we will be coming across root over -1 is actually denoted by I. We will be learning about imaginary numbers, complex numbers. All these imaginary complex numbers, they will be falling under the non-real numbers. And another point we have to know, that's a very, very important point. Any number by 0 in maths is not defined. Remember this. This you should not forget. Not defined. D-E-F-I-N-E-D. Defined. Okay? Means it's not there. For example, like 1 by 0. It's not equal to 0. You cannot write 0. You'll say not defined. 2 by 0, not say 0. It's not 0, it's not defined. 5 by 0, any number divided by 0 will be not defined. That's why 0 has no reciprocal. See, 0, if I write 0 by 1, 0 by 1 is 0. Any number, 0 by anything is 0. But 0, if I make it reciprocal, the reciprocal of 0 is 1 by 0. So 1 by 0 is not defined. Or not defined, we can also write it as infinity. We'll write it as infinity. 2 by 0, it's not defined, infinity. Or you can just write infinity.
3.
Now just remember that non-real numbers means the root over negative numbers. That will be enough. And any number by 0 is not defined or infinity. That just are the 2 points you need to remember at least till class 10 level. And besides all those numbers, whichever number will be coming across, we'll put them under real numbers. Okay. Now, definition was not important. What is this? Real numbers? We'll put them under 2 main groups: rational numbers, and irrational numbers. And irrational numbers. Now, what are rational numbers? If you look at the definition says any numbers which can be written in the form of, if rational numbers can be written in the form of P by Q, where P and Q are integers. Now remember, we have already discussed which are integers, and Q not equal to 0. So the definition, if you look at the rational numbers, are those numbers which can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now forget the definition, concentrate. What is the meaning of that statement? And it means, in simple, it means all those numbers which I can write integer by integer. If I have one integer on top, another integer below, maybe the same integer or different integer, 2 integer, if I can put one integer on top, another one and below, then any number which will have integer on top, one integer below, it will be rationals. Provided the integer which is in the denominator, this Q is the integer which is in the denominator, should not be 0. This integer should not be equal to 0. And why not? Why not? Because I have already mentioned, any number by 0 in maths is not defined. We cannot have that. That's why we like not equal to 0. Okay, then if we come to the irrational numbers, are those numbers which we will not be able to write in the form of P by Q or P and Q. So the rest of the sentence is same. Irrational numbers are those numbers which we cannot write in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay, now let's learn rational numbers with examples. Now the first example. So remember, rational numbers, you can have integer by integer, and this should not be 0. So these are the integers. So if I put any integer on top, say any integer, so 2 here, below 5, they both are integers, so rational numbers. These are different examples of rational numbers. Then if you put another number, say 0, if I take directly 0, any integer, if I take the integer, no denominator, you can write it as 1 and it becomes it's a rational number. So all these are rational numbers. If I take any natural number, say any natural numbers, 3, no denominator, integer here, no denominator, we can take it as 1. So it's a rational number. So similarly, the negative numbers, you can take -3, -5, any number. If there is no number below, we take it as 1. So all these are rational numbers. Or you can say 105 by 181, whatever number. If you have integer on top, integer below, it's rational. Now let's look at the decimal numbers. So in maths, we have actually 3 types of decimals. The first decimal, this type of decimal, say 1.5, which stops. This is called terminating decimal. Terminating, because it stops. Terminating decimal. Now all terminating decimals, you can have many other examples. Say for example, 0.25 does not continue anymore. Or you can write 1.2568 and then stop. So this will be included under terminating decimal. Now this terminating decimals, all the terminating decimals, we can easily write in this form, P by Q. You have 15, after decimal 1 number, so 10 will come, and you can cancel. So we have integer on top, integer below. So the terminating decimals are also rational. So terminating decimals are rational. This also, if I write this, will be 25 by 100. After decimal, we have 2 numbers, so 2 zeros. Okay, similarly, that also can be converted into P by Q. You can cancel and convert it into the lowest term, or you can just cancel 5 3s are 15. So this still remains rational. So the terminating decimals will also be rational. Let's take another form of decimal, The second form of decimal is like this, somewhat like this, where the decimal numbers, this numbers does not stop, but it keeps on repeating. So this is called non-terminating repeating decimals. Non-terminating but repeating decimals. I'll just write non-terminating repeating decimals. They are also called recurring decimals. They are also called recurring. This 3 is recurring. So recurring decimals. Okay. So I can have other examples. Say for example, we can write 0.121212 keeps on repeating. Okay. So this will be non-terminating. Here 12 is repeating. So we can just write 0.12 and we will put a bar here. This will be like this. So in this case we can just write it as 0.3 bar. Bar indicates that it keeps on 3 is repeating. Now this also we can write it. This will be 3 by 9. We cancel, it will become 1 by 3. We will learn how to convert this. So it becomes 1 by 3, and you can see integer on top, integer below. So that means it will be a rational number because integer by integer. Similarly, this one also can be converted. It will be 12 by 99 and then cancel. So we have integer by integer. Again, it will be a rational number. Now let's look at the examples of irrational numbers. Now irrational numbers, remember, we cannot write in the form of integer on top, integer below. We will not be able to write. Now the best examples of irrational numbers are all those radicals with the root numbers. Any root numbers, say root 2, root 3 or root 5, or it can be in this form also, 2 root 3, or it can be 2 plus root 3. This will be considered one irrational numbers, or it can be root 5 by 7. So if you come across any radicals, we will directly say irrationals. Why? Because supposing if you put it, this number we can never write in the form of p by q. Say if you are writing root 2 by 1, this is not integer. This is integer, but this is not integer. So we cannot write. Or if you say in terms of decimals, this root 2 in terms of decimal will be 1.414, and then you will see the numbers which are coming will never repeat. Okay, the repetition will not be the same, and we will see if you keep on calculating the value of root 2, we will find that the number will never stop. The decimal will never stop. This type of decimals, they are called non-terminating because it does not stop. Non-terminating means not stop, and non-repeating means the same number is not repeated. Different numbers will keep on coming. So this type of decimals. So we have learned there are 3 types of decimals. The first 2 forms we have already learned that they are rationals. The terminating decimal was rational. Non-terminating but repeating was rational. But non-terminating, non-repeating will be irrationals. This numbers cannot be written in integer by integer. That's why they are irrationals. Another number, another very common number which we come across is this letter pi. Actually, we use this letter pi in area of circle. What is area of circle? Area of a circle equals to, area of a circle is pi r square. Uses or circumference is 2 pi r. Circumference equals to 2 pi r. So this letter, this pi, we use this letter. So this is also another irrational number. Now, this is actually coming from the definition. This is actually a ratio. Supposing if you have a circle, and this circle, this is the diameter, and if you take another circle or smaller circle, so this circumference divided by diameter, circumference, I'm writing C, circumference by diameter of any circle, big circle, small circle, every circle, they always give us one answer, and that answer is somewhat 3.14, and you will see, and different numbers will keep on coming. Okay, and it is denoted by the letter pi. So actually circumference, this formula of circumference is coming from here only. If you cross multiply, you will get pi into d. D is the diameter. Diameter we can write 2r. Anyway, we'll talk about that later. Anyway, so here the ratio of circumference to the diameter always comes out to be this type of number. Whether the circle is a small circle or a big circle, it will always give us one result. This decimal will never stop. It will be non-terminating, not repeat. But for calculation purpose, when we do this area of circle, for mostly we see that pi, we take it as 22 by 7. But 22 by 7 we can see integer by integer, so this should be rational. Okay, so this is only to make the calculation simple. We put 22 by 7 in place of pi when we calculate area of circle. But actual value of pi and 22 by 7, they differ. The value of 22 by 7, first two places will be same. If we divide 22 by 7, you will get first two places 3.14, and then the numbers after the third place onwards, it will differ from the actual value of pi. So remember, pi is irrational, 22 by 7 is rational. Okay, only for calculation purpose, in place of pi, we substitute 22 by 7 because 22 by 7 is approximately equal to the value of pi. Okay, so for whatever we have discussed, these are the points you need to remember. Non-real numbers, if you see root and the negative number, will be non-real. Any number by 0 is not defined in maths. 0 has no reciprocal. Rational numbers are those numbers which can be written in the form of p by q, where p and q are integers and q should not be 0 because the denominator can never be 0 in maths. In the decimal form of all rational numbers, the rational numbers can be either, it can be of two types, either the first one terminating decimal, which stops, or it can be non-terminating repeating decimal, or we also call recurring decimals. So remember, this non-terminating repeating decimals are also called recurring decimals. Then irrational numbers, we cannot write in the form of integer by integer. The root numbers will be the irrational, pi is irrational. Then decimal form of irrational numbers, all irrational numbers will have only one type of decimal, that is non-terminating, non-repeating decimal. Non-terminating, non-repeating decimal. This will be the decimal form. Okay. Now let's see. There are some common numbers which you come across in maths every now and then. Even numbers, odd numbers, prime numbers, composite, co-prime. That's even numbers. All those numbers which are divisible by 2. Or the numbers which ends in 0, 2, 4, 6, 8. For example, if I write 108 ending in 8, so it will be even number. This is simple. Okay. All those numbers which are not divisible by 2 and ending in 1, 3, 5. Supposing you have 1, 1, 3 ending in 3 or any number from here. This will be all regarded as odd numbers. So okay, this even and odd is simple. Let's see prime number, the most important number here. Prime number. Here, look at the definition. Prime numbers are those numbers which has exactly two factors. Now, what is the meaning of this word factor? I will explain that. That is 1 and itself. Let's take all the natural numbers starting from 1. If I write 1, 1 will be 1 into 1. That means 1 is divisible by 1 only. So this is called the factor of 1. 1 is the factor of 1. 1 has only one factor. If I write 2, 2 can be written in 1 into 2. That's it. It has how many factors? 2 factors. We can see 2 factors here. That is 1 and 2. Now, if I write 3, it will be 1 into 3. Again, 2 factors. You have 2 factors. But if I come to the number 4, if I write 4, it will be 1 into 4. Then we can also write it as 2 into 2. So if I count how many different factors? 1 is 1 factor, 2. And another one is 3. So we have 3 different factors. So this factors means the one which can divide. 1 can divide 4. 4 itself can divide 4. 2 can divide 4. So these numbers which can divide a given number, those are called the factors of the number. So here I have 3 factors. Then if I look at 5, 5 has how many factors? Just 2 factors. This 2 factors, only 2 factors. We come to 6, we have 1 into 6, 1 can divide, then 2 can divide, 2 3s are 6. Okay, 3 also can divide. So how many different factors? 1, 2, 3 and 6. So 4 different factors. Okay, let's come back to this prime number. Numbers having exactly 2 factors. So all those which has exactly 2 factors, not less, not more. This has only one factor. Here you have only one factor. 1 has only one factor. 2 has 2 factors, so 2 will be prime. So I can write 2 here. Then 3 has 2 factors, so 3 will be prime. 4 has 3 factors. So if it has more than 2, so it will be composite. Factors, composite numbers, numbers having more than 2 factors. So this 4 has, the first composite number will be 4. Then Coming to the next number, 5. How many factors? 1 and 5 only. 1 in itself. Just 1 in itself. So it will be prime number. 6. How many factors? 4 factors. 4 different factors. So it will be composite. The one which has more than 2 factors will be composite. The one which has exactly 2 factors will be prime. And if it is less, so 1 is a number. Remember, 1 is neither prime nor composite. So the first prime number is 2, not 1. 1 is neither prime nor composite. That's a very important point to remember. Okay. Then in the same way, if we check, the next prime number will be 5, then 7 has 2 factors only, then 11, 13, 17, 19, and 23, and so on. We'll have many prime numbers or prime factors. Okay. Now this composite numbers, 4 is the first composite number, 6, then we can have the next composite will be 8, and so on. There can be many composite numbers. So now coming to co-prime numbers. Now look at the definition first. 2 numbers. See, this part is very important. There should be 2 numbers. 2 numbers are called co-prime numbers if they do not have any factor in common other than 1. Except 1, there should not be any common factor. Let us take example. First example, say 9 and 25. Let's look at these 2 numbers. If I take 9, the factors of 9 are 1 can divide 9, so 1 is a factor. Then 3 can divide 9, so 3 is a factor of 9. Then 9 itself can divide 9. So these are the 3 factors of 9. If I look at 25, what are the factors? What are the numbers which can divide 25? 1 can divide 25. 5 can divide 25. Then 25 itself can divide 25. So if I look at these 2 numbers now together, I have only 1 which is common factor. I don't have any other factor which is common. No other factor is common except 1. Then these 2 numbers, 9 and 25, we can say 9 and 25 are co-prime. 9 and 25 are co-prime. Okay, but if I take other examples, say 9 again and another number 12. 9, what are the factors of 9? 1, 3, 9. What are the factors of 12? 1 can divide, 2 can divide 12, 3 can divide 12, 4 can divide 12, 6 can divide 12, 12 itself. So these are the factors of 12. And if I look at the common factors, this is a common factor. 1 common factor. Then another common factor. So we have 2 common factors. So these 2 numbers are not co-prime. Not co-prime. So here the highest common factor, we have 2 common factors. Among them the highest is 3. So itself is 3. Here itself is 3. But in this case the highest, the maximum 1 is common. Itself is 1. You can say co-prime itself should be 1. So there's a very important point to remember here. Co-prime itself will be 1. So if you are asked what is the itself of 2 co-prime numbers, itself will be 1. And if you are asked what will be the LCM, what will be the LCM of 2 co-prime numbers, it will be the product of the 2 numbers. It will be the product. This is a common objective question. What will be the LCM of 2 co-prime numbers? LCM will be the product of the 2 numbers. LCM HCF will be 1. Now if I take any 2 prime numbers, say for example 2 and 3, they will be always co-prime. Take any 2 prime numbers, any 2 prime numbers will be always co-prime because they will have no factor in common other than 1.